we've seen the valuations of a bunch of software companies crash because people are expecting AI to commoditize software. And there's a potentially naive way of thinking about things, which is like, look, NVIDIA sends a GDS2 file to TSMC. TSMC builds the logic dies, it builds the switches, then it packages them with the HBM that SK Hynix and Micron and Samsung make. Then it sends it to an ODM in Taiwan where they assemble the racks. And so NVIDIA is fundamentally making software that other people are manufacturing. And if software gets commoditized, does NVIDIA get commoditized?
Well, in the end, something has to transform electrons to tokens. That transformation, the transformation of electrons to tokens and making those tokens more valuable over time. I think that's hard to completely commoditize. The transformation from electrons to tokens is such an incredible journey, and making that token, it's like making one molecule more valuable than another molecule, making one token more valuable than another. The amount of artistry, engineering, science, invention that goes into making that token valuable, obviously we're watching it happening in real time. And so the transformation, the manufacturing, all of this. In fact, I also don't think that the enterprise software companies, the tools makers, most of the software companies today are tools makers. Some of them are not, but some of them are workflow codification, systems. But for a lot of companies, they're tool makers. For example, Excel is a tool, PowerPoint's a tool, Cadence makes tools, Synopsys makes tools. I actually see the opposite of what people see. I think the number of agents are going to grow exponentially. The number of tool users are going to grow exponentially. And it's very likely that the number of instances of all these tools are going to skyrocket. It is very likely the number of instances of Synopsys design compiler is going to skyrocket. And the number of agents that are going to be using the floor planners and all of our layout tools and our design rule checkers, the number of agents that are today, we're limited by the number of engineers. Tomorrow, those engineers are going to be supported by a bunch of agents. We're going to be exploring out the design space like you've never seen explored before, and we're going to use the tools that we use today. And so I think tool use is going to cause these software companies to skyrocket. The reason why it hasn't happened yet is because the agents aren't good enough at using their tools yet. And so either these companies are going to build the agents themselves, or agents are going to get good enough to be able to use those tools. And I think it's going to be a combination of both to support the scale.
It seems like some bottlenecks are easier than others. And so scaling up CoWoS versus scaling up...
I went to the hardest one, by the way.
Which is?
Plumbers. Yeah.
That's true.
Yeah. I actually went to the hardest one.
Yeah.
Plumbers and electricians. And the reason for that is because, and this is one of the concerns that I have about the doomers, describing the end of work and killing of jobs. And one of the things that if we discourage people from being software engineers, we're not software engineers. And the same prediction 10 years ago, some of the doomers were saying that we're telling people, whatever you do, don't be a radiologist. And you might hear some of those videos are still on the web. Radiology is going to be the first career to go. The world's not going to need any more radiologists. Guess what? We're short of radiologists.
Oh, but okay. So going back to this point about, well, how far down the supply chain do you go? Do you go to ASML and say, hey, if I look out 3 years from now, for NVIDIA to be generating $2 trillion a year in revenue, we need way more AUV machines? And
some of them I have to directly, some of them I indirectly, and some of them, if I can convince TSMC, as ASML will be convinced. And so that's we have to think about the critical pinch points. And but if TSMC is convinced, you'll have plenty of EUV machines in a few years. And so none of that. My point is that none of the bottlenecks last longer than a couple, 2-3 years. None of them. And meanwhile, we're improving computing efficiency by 10x, 20x. In the case of Hopper to Blackwell, some 30, 50x. We're coming up with new algorithms because CUDA is so flexible. We're developing all kinds of new techniques so that we drive efficiency in addition to increasing capacity.
Yeah.
And so those are things that none of that worry me. It's the stuff that's downstream from us. Energy policies that prevent energy from you can't grow, you can't create an industry without energy. You can't create a whole new manufacturing industry without energy. We want to reindustrialize the United States. We want to bring back chip manufacturing and computer manufacturing and packaging. And we want to build new things like EVs and robots. And we want to build AI factories. And you can't build any of these things without energy. And those things take a long time. But more chip capacity, that's a 2-3 year problem. More CoWoS capacity, 2-3 year problem.
Interesting. I feel like I have guests tell me the exact opposite thing sometimes, and I don't. In this case, I just don't have the technical knowledge to adjudicate. But
well, the beautiful thing is you're talking to the expert.
Yeah, true. Okay, I want to ask about your backstopping CoreWeave up to 6.3 billion and have invested 2B. But yeah, why doesn't NVIDIA become a cloud themselves? Why doesn't it become a hyperscaler themselves and rent this compute out? You have all this cash to do it.
This is a philosophy of the company, and I think it's wise. We should do as much as needed, as little as possible. And what that means is the work that we do with building our computing platform, if we don't do it, I genuinely believe it doesn't get done. If we didn't take the risk that we take, if we didn't build NVLink the way we built, if we didn't build the whole stack, if we didn't create the ecosystem the way we did it, if we didn't dedicate ourselves to 20 years of CUDA while losing money most of that time, if we didn't do it, nobody else would have done it. If we didn't create all of the CUDA-X libraries so that they're all domain specific, this is a decade and a half ago, we pushed into domain specific libraries because we realized that if we didn't create these domain specific libraries, whether it's for ray tracing or image generation or even the early works of AI, these models, if we didn't create them for data processing, structured data processing, or vector data processing, if we didn't create them, nobody would. And I am completely certain of that. We created a library for computational lithography called cuLitho. If we didn't create it, nobody would have. And so accelerated computing wouldn't advance the way it has if we didn't do what we did. And so we should do that. We should dedicate our company, all of our might, wholeheartedly to go do that. However, the world has lots of clouds. You got to place a PO. If you don't place a PO, now of course there are stories about that. Like for example, all of this kind of started from it was an article about Larry and Elon having dinner with me where they begged for GPUs. Yeah. That never happened. We absolutely had dinner. And it was a wonderful dinner. In no time did they beg for GPUs. And so they just had to place an order. And once they place an order, we do our best to get the capacity to them. Yeah. We're not complicated.
Okay, so it sounds like there's a queue, and then based on whether and so if Chinese companies and Chinese labs and the Chinese government had access to the AI chips to train a model like Claude Mythos with these cyber offensive capabilities and run millions of instances of it with more compute, the question is, is that a threat to American companies, to American national security?
First of all, Mythos was trained on fairly mundane capacity and a fairly mundane amount of it by an extraordinary company. And so the amount of capacity and the type of compute it was trained on is abundantly available in China. And so you just have to first realize that chips exist in China. They manufacture 60% of the world's mainstream chips, maybe more. It's a very large industry for them. They have some of the world's greatest computer scientists. As you know, most of the AI researchers in all of these AI labs, most of them are Chinese. They have 50% of the world's AI researchers. And so the question is, if you're concerned about them, considering all the assets they already have? They have an abundance of energy. They have plenty of chips. They got most of the AI researchers. If you're worried about them, what is the best way to create a safe world? Well, victimizing them, turning them into an enemy, likely isn't the best answer. They are an adversary. We want the United States to win. But I think having a dialogue and having research dialogue is probably the safest thing to do. This is an area that is, the fact of the matter is their AI development is going just fine. And the best AI researchers in the world, because they are limited in compute, they also come up with extremely smart algorithms. Remember, what I said. I said that Moore's law is advancing about 25% per year. However, through great computer science, we could still improve algorithm performance by 10x. What I'm saying is great computer science is where the lever is. There is no question. MOE is a great invention. There's no question. All the incredible attention mechanisms reduce the amount of compute. We have got to acknowledge that most of the advances in AI came out of algorithm advances, not just the raw hardware. Now, if most of the advances came from algorithms and computer science and programming, tell me that their army of AI researchers is not their fundamental advantage. If we scare this country into thinking that AI is somehow a nuclear bomb, so that everybody hates AI and everybody's afraid of AI, I don't know how you're helping the United States. You're doing a disservice. If we scare everybody out of doing software engineering jobs because it's going to kill every software engineering job, and we don't have any software engineers as a result of that, we're doing a disservice to the United States. If we scare everybody out of radiology so nobody wants to be a radiologist because computer vision is completely free, and no AI is going to do a worse job than a radiologist, and we misunderstand the difference between a job and the task, the job of a radiologist, patient care, task to read a scan. If we misunderstand that so profoundly and we scare everybody out of going to radiology school, we're not going to have enough radiologists and good enough healthcare. And so I'm making the case that when you make a premise that is so extreme, everything goes from zero or infinity, we end up scaring people.
Suppose the deep learning revolution didn't happen. What would NVIDIA be doing? Obviously games, but given
accelerated computing. Accelerated computing. The same thing we've been doing all along. The premise of our company is that Moore's law is going to, more general purpose computing is good for a lot of things, but for a lot of computation, it's not ideal. And so we combined an architecture called a GPU, CUDA, to a CPU so that we can accelerate the workload of the CPU. And so different kernels of code or algorithms could be offloaded onto our GPU. And as a result, you speed up an application by 100x, 200x. And where can you use that? Well, obviously engineering and science and physics and so on. So data processing, computer graphics, image generation. I mean, all kinds of things. Even if AI doesn't exist today, NVIDIA will be very, very large. Yeah. And so I think the reason for that is fairly fundamental, which is the ability for general purpose computing to continue to scale has largely run its course. And not the only way, but the way to do that is through domain specific acceleration. And one of the domain that we started with was computer graphics. But there are many other domains. I mean, there's all kinds of scientific particle physics and fluids and so structured data processing, all kinds of different types of algorithms that benefit from CUDA. And so our mission was really to bring accelerated computing to the world and advance the type of applications that general purpose computing can't do, and scale to the level of capability that helps break through certain fields of science. And so some of the early applications were molecular dynamics, seismic processing for energy discovery, image processing, of course. And so all of those kind of fields where general purpose computing is just simply too inefficient to do so. And so, yeah, if there's no AI, I would be very sad. But because of the advances that we made in computing, we democratized deep learning. We made it possible for any researcher, any scientist, anywhere, any student to be able to access a PC or, a GeForce add-in card and do amazing science. And that fundamental promise